Ah, yeah, I know. I saw that Irrational too, and I was like, bro, why are you so mad at me? Like, why you gotta have eyes and such? Like, I don't. What is it called? Anthropomorphication? I don't know. I can't say that word, but it's when you have something that's not alive or human and you make it look human, and it puts me not. Anyway, it's cray cray. That's my point. Irrational numbers, and the reason that you got this pi symbol, the 3.1415, on and on and on and on, that really smart people memorize and can say for like hours at a time, is because this one is your main irrational number. There are very few irrational numbers that you're going to run into, so I want to go over the entire real number system and compare all of them, review them, and then throw in irrational, and then we go through some other vocabulary that could fit into things being irrational. Okay? So we know that the natural numbers, those are your baby numbers, those are what you count by. Zero doesn't exist whenever you're a young child. But then you start getting into whole numbers, and that's when you throw in zero, and then all of your natural numbers, or your baby numbers. And then you have all the whole numbers, including zero and their opposites, which would be negatives, which would be your integers. That does not include decimal points, that does not include fractions. Then you get into rational numbers, and that includes everything that we just mentioned before. This is where integers could be positive and negative, including zero with fractional parts or decimals. Those all fit into the real number system. But in addition to that, there are also irrational numbers. Not only are they crazy and no one understands them, they are literally irrational numbers. I'm sorry, it's been a tough week. Irrational numbers are the ones that you're like, what? Just like an irrational person. If you run into an irrational person, you're like, what? What are they talking about? Well, like if you were a number and you were talking to an irrational number, you'd be like, what? What is this? What's going on? So, I mean, it's if you think about it from person to person, a majority of the people you run into are rational people. Okay, and they're all things that you've seen before. You're like, oh, that person's got two eyeballs, and you're like, that seems normal to me. But then all of a sudden, you run into a cyclops. They have one eyeball that's really huge in the middle of their forehead, and you're like, whoa, what's going on there? That doesn't make sense. That's where you fit into your irrational. Think about how many normal people you run into, and then think about how many irrational people you run into. So the vocabulary we've already gone over is rational. That's when you can include fractions and decimals. Anything that can be written as a fraction or a decimal is an automatic rational number. So you're sitting there going, well, what can't be written as a fraction? And I'll get into that. Integer, positive and negative, including zero, no fractions, no decimal, whole numbers, all their baby numbers plus zero, and the natural numbers, your baby numbers. The new words we're going to be talking about today are radical, whoa, bro, and then terminating, which means stuff stops. I'm going to terminate the decimal. And then repeating, which means that it's just going to keep going on and on. It's going to keep going on and on. It's going to keep going on and on. It's going to keep going on and on. You thought I was only going to do it 3 times, but I did it 4. And then we're going to throw in irrational. So here's a little table of some examples, okay? These things right here, these little lightning bolts that are over the number, those are called radicals. Radicals represent square roots, cube roots, all kinds of roots. And you're like, well, what's a root? I'm going to get into that on the next one. So if you took the square root of 8, I'll take the square root of 8 right now, and I'll tell you what it is. It is 2.828427127. So you could think that maybe there's a pattern there, but there's not. That's going to keep on going, and there's not going to be a pattern. It's not going to go 8204, 8204, 8204, 8204. That would make it repeating. So irrational numbers are whenever you simplify a radical or you simplify a fraction, and for some reason, it just doesn't work. It actually just keeps going. And you're sitting there going, what? And whenever you do the what, that's whenever you know it's irrational. I'm going to go ahead and do the square root of 1.6 just to give you another example. That is 1.264911061. I have no idea if that's a pattern, but the fact that I don't know tells me that it's irrational. Typically, like with 1/3, this is a rational number because it's written as a fraction. It can be written as a fraction because it's a repeating decimal. Whenever you divide it, it's going to end up being a whole bunch of threes. Now, regardless of how simplistic that pattern is, it is still a pattern. It's predictable. You know what's coming next. Guess what number comes after this one? You get it, a 3. So that makes it a repeating decimal. Repeating decimals fit in the rational number category. Now, take a look at this one down here. It goes 3030. Oh, snap. Is that a pattern? Oh, dang it. There's another 0. Then 30003. So the pattern broke up, meaning there is no pattern. The primary one you're going to run into is pi. I covered it up with this weird number, the irrational number. Get out of my way. So whenever you calculate pi, you know that for a fact that that's like the one number you probably know right now off the top of your head that you're going like, yeah, I don't know the entire number, which makes it irrational. It does not follow a pattern, and it goes on forever. So non-terminating, but doesn't repeat. So if it keeps going and it doesn't repeat anything, it's an irrational number. Those are the two criteria for irrational numbers. So this one right here, 0.21 or 21 hundredths repeating, you know what comes after? 21. Oh my goodness, it follows a pattern, making it rational. 7/8 would be, let's just go ahead and divide it up and see. 7 divided by 8, that gives you 875 thousandths. And what follows that is a whole bunch of zeros. Okay, so that means it's terminating, thus making it rational. So this is the square root of 9 as a whole number. We're going to get into square roots right now. 8 divided by 2 is 4. So if you can simplify it, it'll turn it into the actual number it is. It'll fit into a category once you simplify. Okay. So radicals. I call it a lightning bolt. I don't know, maybe like a part of a roof of a house. You know, like if you were to like do this and then like you got the garage over here, you know, or something. Maybe a window. I don't know. Put a door. Anyway, I'm getting carried away. This is called a radical. You're probably not going to hear the word radical very often, but you are going to hear square root. All right. So a square root, much like multiplication is to division. All right. So if you want to undo multiplication, you divide things. If you want to undo addition, you subtract things. If you want to undo a square of a number, you take the square root. So if a number is a square, it would also be referred to as a perfect square. Let's talk about some perfect squares. 3 to the second power. That means 3 times another 3. There's going to be 2 3s that are multiplied. Okay, that gives you 9. That's why this is called the root, okay, or the base. So whenever you solve a square root problem, like what's the square root of 9? Basically what that's asking you is what number multiplied by itself is 9? And the answer is 3. So it's undoing this square. So you can see how these undo each other. Just for another example, and this one would end up being irrational because it's not a perfect square. Perfect squares would be 4 because 2 squared, 3 squared is 9, 4 squared is 16, 5 squared is 25, and you can just keep on counting up and multiply the number by itself. Those are called perfect squares because they make a 3 by 3, and guess what? A 3 by 3 makes a square. So does a 5 by 5, 5 units by 5 units, the length and the width makes a square. That's why they're called square units, and that's why it's also called a square because it's made of squares. So let's talk about 6. We know that 6 is not a perfect square. So if you know it's not a perfect square, it's irrational because the only thing you can take the square root of is a perfect square. And we already know that the perfect squares, 6 is not one of them. 36 is, and then the square root of 36 is 6, but the square root of 6 is 2.4494897428. And, you know, I guess that's where you could think of it as that's radical, bro, because that's pretty crazy. And here's a fail-safe for you. If you're looking at a square root and it's a number that you know fits as a perfect square, like for example, 81. If we had the square root of 81, 81 is a square because it's a 9 by 9. So 9 times 9 would be the square root of 81. So any number multiplied by itself is the answer to a square root. Okay? Over and over and over. If you get any confusion about that, please reach out, contact me. Just know that the non-perfect squares are going to be your irrationals. You're not going to run into those very often. You're going to primarily be dealing with pi. All right, so natural numbers. Your baby numbers, 1, 2, 3, 4, 5. Whole numbers, your baby numbers plus 0. And then integers, baby numbers plus 0 and all of those opposites. So 1, -1, 2, -2. Rational is able to be any of those, plus you can throw in fractions and decimals. And then irrational cannot be written as a fraction. It's non-terminating, and nor is it repeating. Okay, so very few numbers are irrational that you're going to run into. A majority of the stuff that you run into is rational, but just know that all of those together fit in the real number system. Okay, so very vocabulary intense. All right, so what I want you to do is I'm going to put something on here, and all I want you to do is like just take a moment and go like rational, irrational, natural, whole, and then we'll just just shoot back and forth, just checking. All right, square root of 5. What do you think? Natural, whole, integer, rational, irrational. Okay. Well, I mean, we know that 5 is not a perfect square. I don't know of a number that multiplies by itself to make 5. So we would know that this is irrational, and we know that it fits in the real number system because irrational numbers are in the real number system. Okay, so let's take another look. 5/7. Okay, and anytime that you're sitting there going like, heck, man, I don't know. All you got to do is just go, hold on. That's a fraction. So if it's a fraction, it's automatically rational because it includes fractions and decimals. Okay? So if it can be written as a fraction, then it's rational. It's not an integer, it's not a whole number, it's not natural, it's not irrational because it's written as a fraction. But it is a rational and fits in the real number system. So let's just go with, I mean, you could even run into stuff like this. 5 times pi. Okay, so I mean, we already know that pi is, yes, irrational. Very good. I heard you through the future you watching this into the video, transmitting your future voice into the past to me when I was recording this. That was a lie. So if you have pi and it's irrational and you multiply it by 5, it's still irrational. So just know that if you have something irrational and you multiply it or divide it by anything, it's not going to make it rational. You can't make something irrational rational. Let's put it that way. So if you have anything including irrational numbers, it will remain irrational. So this is irrational. It fits in the real number system. Okay. So let's try this. What do you think that is? -5/10. If you said rational, you'd be correct. If you said integer, you'd be wrong because it cannot include fractions or decimals. If you said whole number, you'd be wrong because that's part of a number, not a whole number. If it's a natural number, it would be a baby number. I know you didn't grow up counting by -0.5, so this is also a real number. So let's just go simple. 5. Well, you're like, okay, I was counting to 5 when I was a baby. It's natural. It's a whole number. That's good. Okay, so 5. So it's natural whole. And it is an integer because it would be the opposite of -5. So we have an integer. It can be written as a fraction or a decimal. 5 divided by 1 is 5. Or we have 5.0. There's your decimal. So we have a rational number, and it fits into the real number system. Okay? So you can see a majority of the things I'm writing are not irrational. All right? So your assignment's coming up, and don't act like you don't know what I'm talking about. I thought it was funny because I was typing this to myself, and then I put that, and I need to know what you understand. And then I waited for a minute. Work to do. Hello? And it's like, I can't hear you. I'm sorry. What? That would mean you don't have to do it because you don't understand what I'm saying. Get it? So there's going to be sets of numbers. all right? Like there's going to be a 3, let's say, and all you have are these little bubbles. And I want you to take these bubbles, and if you want to draw the bubbles and fill them in and be like, that's a natural number, that's a whole number, that's an integer, that's a rational number, and that's an irrational number, an irrat, then you can go like this, okay? Or you can just write these things next to the number. I don't really care. I just want you to practice, and I want to be able to see it so I can see if you understand what it is and what it isn't. And the main focus is going to be on the irrational part. The irrational ones are the trick ones. Those are the ones that you're going, huh? And whenever you go, huh, that means it's probably irrational. And it's going to be very rare that you're going, huh? So just know that whenever you have an irrational and you go, huh, that is going to be the only one it fits into. And just pay attention to also if it's a real number, because every single number you're going to be given is going to be real. Okay? Unless for some reason you're given an imaginary number and your teacher's hardcore, and I don't know what to tell you. So let's see what you can do with all this. And there's plenty of links that will make you go through this in practice. Once you're identifying these things and you're working them out, like you see a square root of 25 rolling by, you're going to be like, oh, wait, square root of 25 is 5. So that, okay, that's a rational number. That's an integer. That's a whole number. That's a natural number. Bam, fits in there. Okay. Best of luck. Let me know if you need anything.